Hey, welcome to another Mr. Nelson's chemistry class. Again, we're going to be working on stoichiometry, mass to mass. This time it's practice sheet number 6, problem number 1. One thing about practice number 6 is that there's only 2 problems, but they're a little bit longer problems, a little more in detail, and some of the stuff really doesn't matter. So let's go ahead and read the problem and see what we have. When very small samples of oxygen are needed in a laboratory, the gas may be generated by a number of simple chemical reactions, such as the decomposition of potassium chlorate. Well, potassium chlorate decomposes when heated, leaving pure oxygen and potassium chloride. In the last part, what mass of oxygen is theoretically produced when 5 grams of potassium chlorate is heated? Now, there's a couple things with this when we're writing out the skeleton equation. Is where do we begin? Well, this whole first part, right here, from there up to there, that is just blah, 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 blah. It's an explanation of why we might need to do this reaction. So the important part is, for the skeleton equation, is from here to there. So potassium chlorate decomposes. So that means it's going to break apart. So that's our reactant, is potassium chlorate. And it's done this when it's heated. Now, heat is just a catalyst to get the decomposition going. And it's going to leave pure oxygen and potassium chloride. So we're going to start off by doing potassium chlorate. So if I come over here, we know that the charge of potassium is going to be +1. And that's because it's in column 1. Now, chlorate, on the other hand, is one we have to figure out what it is. I don't know off the top of my hand. It could be a -1. I know chloride's a -1, but it's chlorate. So let's go to our packet and scroll down to the polyatomic ion sheet, and let's find chlorate. Chlorate is a -1. It's ClO3. So if we go back to our thing, we know that, or to our question, we know that it's a -1. So we only need one of each one. So we're going to put our potassium down, which is K. And our chlorate was ClO3. Okay. Now what's going to happen with that is we're going to kind of tab over. It's going to decompose, which means that's the only one it's going to break apart. So that's going to equal or yield oxygen. There we go. And potassium chloride. Okay, right here. And potassium we know is a +1. So again, put all these things down so you know where they're at. So it could be a +1. And chloride is a -1. So we know that we only need one of each one of those. So that's going to be potassium, which is going to be K, and Cl. So we have the complete skeleton equation, except we have a problem. Hopefully you've caught it, and that is oxygen. Oxygen is by itself. We always have to ask the question, is it diatomic? Well, oxygen is diatomic. We see it as O2. Excuse me. There we go. So now we have our completed skeleton equation. So what do we do next? We balance the equation. So again, what I would like to have you do is go ahead and write down all the elements below this. We have potassium, we have chlorine, and we have oxygen. And we're going to do that for both sides of the equation. So once I get this over here, I'm going to do the same thing on this side. So we have potassium, we have chlorine, and we have oxygen. Now we're going to write down how many we have in the skeleton equation right now to see if it could be already balanced. Let's just see what it is. So we know that we have 1 potassium on this side, we have 1 chlorine, and we have 3 oxygen. And again, we counted these by looking at the subscripts. If it doesn't have a subscript, that means that it's 1. Okay, so oxygen has 3, chlorine 1, and potassium 1. So let's go to the other side. On the other side, we have potassium, which I have 1. Chlorine, right here, no subscript, so that means there's 1. Oxygen, though, we have a subscript of 2, so we have 2. So I have to put a 2 here. Okay, so the only one that we can do is we can do oxygen. Now, there's one thing about oxygen. This side right here is always going to be positive. This side might be positive or negative. So what we're going to do is we're going to make this other side that's odd, make it positive. The easiest way to do that is to go ahead and put a 2 there and double that. Now I doubled everything that I have. So I have 2 potassium, I have 2 chlorines, and now I have 6 of the oxygen. Okay, and I'm going to just kind of shade these through, or we can just do Shift, Alt, and 5, and that's might be an easier way to do it. Okay. So now we got to come over on this side, and we know that we can change this by putting a 2 right here to be our 2 that we have there and our 2 that we have right there. Okay, well, what about oxygen? I need 6. So I have to put what number right here? You got it. I got to put a 3. So that changes this to a 6. So that means I can take all of these and cross them out. And once I cross them out, now I have a balanced chemical equation. My molar ratio is going to be 2 to 3 to 2. Okay, and that's what I'm going to need to go from the number of 1 to the number of something else. And I need that molar ratio. So the next part of our step is to say, we're going to start our stoichiometry, but we're going to start it with the number that's in the equation. In this case, we have 5 grams of potassium chlorate. So there's our potassium chlorate. And so you know that we're going to start off with 5.00 grams of KClO3. Okay, now again, we have to convert this to moles, and how we're going to do this. So grams to moles, and we're going to use our conversion factor of molar mass. So 1 mole equals the molar mass of potassium chlorate. So we know that 1 mole of potassium chlorate, and I'm just going to copy this for our purpose right now. So we're going to copy that, and we'll paste it right here. And we know that once we get down here, we're going to go ahead and put down the number of grams. Now, in order to figure out the number of grams of potassium chlorate, okay, we have to make sure, okay, that we figure out the molar mass. Well, how do we figure out the molar mass? Well, we take our potassium chlorate down here. And again, you need to show all this work. At one time, I was saying you didn't have to, but because of the way that we're doing things virtually here, I need to see all your work and how you did it. So we have all of our different elements. We have potassium, chlorine, and we have oxygen. Well, how many of each one do we have? Well, in this equation right here, or formula, we have 1 potassium, we have 1 chlorine, and we have 3 oxygens. So we're going to multiply that by the atomic weight, or the weight of each one of these. And once we get that, I know what oxygen is. Oxygen is 16. So 3 times 16 equals 48. Chlorine is 35. Okay, and that's going to equal, again, 35. But what about potassium? Well, let's go to our periodic table. And I may not know it off the top of my head, but I believe it's 39. Let's go to potassium. Right here it is, and it is 39. So if we go back to our question, we can see that 1 times 39 equals 39. Now what we're going to do is we're going to add all these together. So we're going to take 39 plus 35 plus 48 equals 122. So the molar mass is equal to 122. That's grams of potassium chlorate. Okay, so what do? We're going to put this right here, this 122 grams of potassium chlorate, and we're going to copy it and we're going to paste it right here. Once I paste it right there, I know that I can get rid of something. I can get rid of my grams of potassium chlorate here, and I can get rid of my grams of potassium chlorate here. Now our next step, according to our stoichiometry map, is we have to change moles of potassium chlorate to moles of oxygen, because that's what we're looking for. And I have to change it to moles before I can change it. And we're going to use our balanced chemical equation to do this. So since I have moles of potassium chlorate here, down here on the bottom, we're going to put the number of moles, and that's going to be 2 moles, because that's where we got it from that, because 2 moles of potassium chlorate equals 3 moles of oxygen. So we're going to put down here our 2 moles of potassium chlorate. We're going to paste that, and again we're going to cross that out. And on the top we have to put, what are we going for? We're going for oxygen. So we're going to put down 3 moles of O2. Now I can get rid of my moles of, excuse me, I don't need 100 in that. I need to get rid of that. This should be moles of KClO3. Now I can get rid of that. Now I see it right. So we're going to get rid of this. And we're going to get rid of this one right here. Now I have it in moles of oxygen, or O2. So we're going to underline that. And now I got to convert it from moles of oxygen to moles, to grams of oxygen. So we know that 1 mole of oxygen equals the weight in grams of oxygen. We know since we have 2 of them, that's going to be 32. So we're going to put 1 mole of O2. That's going to weigh 32 grams, or is equal to 32 grams of O2. I can get rid of my moles of O2 there and here. Now what I have to do is I have to go ahead and do the math. So when I do the math, I just need to multiply by the top, divide by the bottom, but I do not need to do any of the ones. So we're going to go ahead and put our calculator out here, and we're going to take 5 divided by 122. We're going to multiply by that 3 and divide by 2, and then we're going to multiply by 32. That's going to equal 1.967. So we're going to put that in there. 1.967, and that's going to be grams of O2. Now we have to go ahead and go back to our original question, and figure out how many significant figures. Here's our number. We have to determine, we know that the 5 is significant, but are the zeros significant? Well, because there's a decimal in the number, that means that the 0 is significant. So our 0 is significant there. Let me change that back to the right one. So that means I have 3 significant figures, so I'm going to put a line right here after my third one. The 7 says we round up, so I can get rid of that one, move that back, put that in there. There's my final answer. So in order to convert from 5 grams of potassium chlorate, when it decomposes, it's going to create 1.7 or 97 grams of oxygen. We need to highlight that, and we're done. There we go. There's our answer. Hey, as always, go Mohawks. Nelson out.